Let's go ahead and finish up chapter 9, section 2. We started last time. um, let's look at example 5 first. I don't know if we did this one or not, but let's look at polar equations of circles. Okay, so in this example, we're given r equals 4 sine theta. How far did we get last time?
We went to identify and graph a polar equation as a vertical line.
Okay, yeah. All right, thank you. Thank you.
Mm-hmm.
So now the next one we're going to do is our circles. We're going to identify this one. Here are my steps. Identify the graph as a circle. If it's a circle, then we have to have one of two things. Either it has to be defined as a sine theta or a cosine theta. Okay, we have sine theta. So we have a sine theta. So next step. So we have r equals 4 sine theta. Now we have to make this equation into something we know. So we multiply r to both sides. So it gives us r squared equals 4r sine theta. Third step. Substitute r squared equals x squared plus y. Remember, it's a circle. So there's our equation of a circle at the origin. So we have x squared plus y squared equals 4r sine theta. Okay, now from up here, well, from our earlier discussions, remember we had y is equal to r sine theta, x is equal to r cosine theta. So since that is there, we have x squared plus y squared equals 4y. We're using this one. Because now we're in rectangular coordinates. We can now figure out this one and graph it. Set equal to 0 and solve. So we move this one over. So we have x squared plus y squared minus 4y equals 0. This is a form of a circle. So we have to do now, use the complete the square property. Because we need to have a squared term here. So we have x squared plus y squared minus 4y. We have to add b over 2 squared. So we have to add 4 over 2 squared to both sides. Only do inside the parentheses, so it's 2 squared. On the right-hand side, work it all the way out. So 4 divided by 2 is 2. 2 squared is 4. We've completed the square here, so we have x squared. Whatever's under the square, the first sign, whatever's under the square. So it's y minus 2 squared. It's the algebra part that's going to get you. Now we know this is a circle because we have the, remember, let me go to the next page. So we have a circle is x minus h squared plus y minus k squared equals r squared. The center is at hk and the radius is r. So in our example, we had x squared plus y minus 2 squared equals 4. Yeah. So our center, since there's no h, it's at 0. And the k, it's y minus k, so k is 2. So the center's at 0, 2. The radius, r squared equals 4. So square root that equals 2. So our center is at 0, 2. The radius is 2. So I put it down there, put it down here, put it down there, and combine all the dots. So there's my circle graph. And do the next one. Identify a graph, a polar equation. This one's also going to be in the shape of a circle. R equals -2 cosine theta. So the same solutions. We have this equation. First thing you do is multiply r to both sides because we need to make it into an equation of a circle. R squared is -2r cosine theta. R squared is x squared plus y squared. Since this is the cosine, it deals with the x component. So multiply by r, set equal to 0. So we're going to move that over. So we have x squared plus 2x plus y squared equals 0. Complete the square. So we have x squared plus 2x plus 2 over 2 squared. 2 over 2 squared. No, it's whatever's in front of the x. I divide it by 2 and I square it. So we have x squared plus 2x plus 1 squared. 2 of 2 is 1, so it's 1. I take whatever's under the squares and the first sign. So it's x plus 1 squared plus y squared equals 1. It's an equation of a circle. The center is at -1, 0, and the radius is 1. Center's at -1, 0. Radius is 1, so up 1, over 1, left 1, down 1, and connect the dots. So far, so easy. Here's a theorem. Suppose A is a positive real number. Then 4 things can happen. Here's our equation and what it means. Description. First one, R equals 2A sine theta. So we have the center, which also gives us the radius. That's the A part. The center, since it's a radius, so it's 0A, and it's rectangular. These are all going to be in rectangular coordinates. So if we have this, we know the center, and we have the radius. The radius is A, and the center is going to be at 0A. At -2A sine theta. The radius is at A. Center is at 0, -A. Now we're at RCC. R is equal to 2A cosine theta. Radius is A. Center is at A, 0. The radius is A. Center is at negative A comma 0. So it pretty much gives us an idea of what we're gonna be looking for when we start doing these graphs. All right, let's look at symmetry. Testing polar equations for symmetry. Because we're going to be able to go from r theta and look at r negative theta. If it's just the angle, if that's all it. So here's the r. This is theta. And this is negative theta. So it's symmetric about the polar axis. Remember, the polar axis is the x-axis in polar coordinates. That's our first one. Another form of symmetry we'll look at is if we do a shift or shift in angles. So there's r, that's my theta. So now, since this is theta, it's off the x-axis or the polar axis. What this one says, I'm at pi and I subtract theta. So it's symmetric about the line theta equals pi over 2, which is straight up and down. It's in rectangular coordinates, our y-axis. Now, if we shift the radius, remember what that does. Let's draw the graph for this one. So here we have our radius, some angle theta, negative r theta. It's the same theta, but now we go the opposite direction. So we add pi to it. And there are 3 tests for symmetry that we're going to look at. Remember, whenever you have a negative radius, it just, whatever radius you have, it's just the opposite, it's at the other end. Test for symmetry. See if it's symmetric with respect to the polar axis, which is the x-axis. Replace theta with negative theta. If an equivalent equation results, then the graph is symmetric about the polar axis. Two, symmetric with respect to the line theta equals pi over 2. Replace theta with pi minus theta. If an equivalent equation results, then the graph is symmetric about the line, the vertical line, pi over 2. Symmetric with respect to the pole, which is the origin. Replace r with negative r. If an equivalent equation results, then the graph is symmetric about the pole. All right. Let's look at some examples here. R equals sine 2 theta. So Is it about polar axis? Is it about beta equals pi over 2? Is symmetric about the pole? Test for symmetry. So polar axis, we switch theta for negative theta. So we go from here. Are the set values the same? My ankle's there. A negative angle. So it's not because it won't give you the same value. This will give you a positive, this will give you a negative. How about sine 2 pi theta and r equals sine 2 pi minus theta. Sine theta, sine cosine theta. So this is going to be sine 2 pi minus 2 theta. The difference of two angles. Sine 2 pi sine 2 theta minus cosine 2 pi cosine 2 theta. 2 pi is 0. That's 1. So no, because to start off with this, we change to this, so it's not the same. So r equals sine 2 theta. Negative r equals sine 2 theta. Please. The polar axis Do I get an equivalent, do I get an equivalent function? So if I have R2 theta. We make it negative. Sine is a odd function. So there's opposite. Okay, that one will work. Because if I do that, then I get negative sine 2 theta. So if I get a negative angle, I'll make it negative, so I get the same. So that one works. So it's symmetric about that one. So 2 pi is 2 theta. This one will work also then. Just a double angle in there. I want to say yes to this one. And I do look like this one. If I 2 theta. If it's polar axis, then that one, so it's all three of them. Graph polar equations. By plotting points. R equals 1 sine theta. Check for symmetry. First one, polar axis. R equals 1 minus sine negative theta. So that one changes sign, becomes R sine theta. So that's plus and that's minus. So that fails. Next one is replace theta with R pi minus theta. So it's 1 minus sine pi minus theta. Would just look like this is the difference of two angles. Sine pi cosine theta minus cosine pi sine theta. Sine pi is 0. Cosine with negative sine theta. At pi is -1. So it stays. So that one passes. And the pole. Place r with -r. One minus sine theta becomes -r. -1 plus sine theta. That's the same. Because it ends up with the opposite sign. Step 2, this is step 1. Step 2. Since it's symmetric about that. This is values I'm using. From -pi/2 to pi/2. So here's my angle. R equals 1 minus sine. One minus -1 equals 2. So we got a point at -pi/2. Negative pi over negative, so it's -radical 3/2. 1 plus 2 plus radical 3/2. pi over 4. Radical 2 over 2. So 2 plus radical 2 over 2. So -1/2 makes it 2 plus 1 over 2. At 0, 1 minus sine of 0 is 1. One minus pi over 6. 1 minus pi over 6 is 1/2. Is 1/2. That's not good. Sharing stop. Yeah, we have a issue here. It stopped sharing. There. 1 minus radical 2 over 2. 1 minus sine pi over 3. 1 minus radical 3 over 2. One minus sine pi over 2. This 1 equals 0. So now all these points. Now, the interesting about graphing these points. So for example, the point 0, 1, there's no, the radius is 0. Oh, that's the theta. Dang, I have it backwards. I have these backwards. This is theta and this is r. Yeah, flip these around, so it's, the radius is 1, theta is 0. Pi over 6, 1/2. Pi over 4, 2 minus 2. Two minus almost half pi over 3. This is 1. And it's symmetric about the symmetric about the vertical line. Negative 3 pi over negative pi over 2. So it's at 2. It looks something like that. It's a cardioid. Let me write these out. This is cardioids have these focuses. The radius is a times 1 plus cosine theta. Radius equals a1 plus sine theta. 1 minus cosine theta because it's symmetric. 1 minus where a has to be a positive number. Example 8. Next one is what's called a limason. Typically, limasons they have two types. You have one that can have a loop inside there, and another one where you could have just a dip. That's a limason. And these are because of limasons, their claim to fame is this type of structure. A minus b cosine, a minus b sine. So when you have an integer plus or minus a coefficient, sine, cosine, that's a limason. Step 1, symmetry test. Reason we test for symmetry first is because that way we only have to do half of the graph. If it's not symmetric about the pole, about the polar axis or the vertical axis, then we don't have to worry about that graph. It'll have its own points everywhere. So the first, the polar axis, let's look at that. So we replace so 3 plus 2 cosine theta. I replace it with 2 cosine negative theta. Since cosine is an even function, it doesn't change it, so it passes that. So it passes the polar test, polar axis test. Next, let's do the vertical line y equals pi over 2. So we have 3 plus 2 cosine theta becomes our 3 plus 2 cosine pi minus theta. This is a difference in angles, so we have cosine pi cosine theta plus sine pi sine theta. Sine pi goes to 0. Cosine of pi is -1. Since that's a negative, it changes the equation. So it fails that. And last one is the pole test. So R equals 3 plus cosine theta. So it's 3 plus 2. So it changes sign. So I have negative R is -3 minus 2 cosine theta. So if we did that, then we factor it out with the same thing. But it's not the same. Because whenever you change that, it should equal the same thing, which it doesn't. It's the negative of it, so fails. Now the graph. We have to get points. Since we're doing cosine, 3 plus 2 cosine So at 0, we have R equals 3 plus 2 cosine 0. 3 plus 2 equals 5. So it's 5, 0. Pi over 6. 3 plus 2 cosine pi over 6 3 plus 2 radical 3 over 2. 3 plus radical 3. Pi over 4. Three plus 2 radical 2 over 2. 3 plus radical 2. Two cosine pi over 3. 2 times 1/2, which is equal to 4. Or radical 3, pi over 3. Pi over 2. 2 cosine pi over 2. That's 0, so it equals 3. With 2 pi over 3, 2 pi over 6, 2 pi over 4 is pi over 2. So 2 pi over 3. And pi over 6 on the other side. 1 pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. So we need 5 pi over 6. Over 3. Pi over 3. Negative 1/2. So that makes it 2. 2 pi over 3. 3 plus 2 cosine 5 pi over 6. 3 plus 2, 5 pi over 6 is negative radical 3 over 2, so it's in the second quadrant. So it's 5 pi over 6, 3 minus radical 3. And that pi we got. Like that pi we get. Cosine of pi is -1, -2, so it's 1. Let's dig into those points. If radius is 0, I mean, if theta is 0, then it's 5. That's first one. At pi over 6, it's 3. Pi over 6 is 3 plus 1. Pi over 4. Pi over 3. Pi over 3 is 4, so that's up here. Mm, 3 pi over 6, 2 pi over 3. It's 2. Here's 2. So it's over here. 5 pi over 6. Radical, that's 2 this. Something like that. But I should draw it with a calculator. Graph a polar equation in the form of a meson with an inner loop. R equals 1 plus 2 cosine theta. Okay, now since it's an inner loop, A plus B cosine theta, A plus B sine theta, A minus B cosine theta, A minus B sine theta. Those are for inner with inner loops. Okay. Tests. Polar axis. Cosine theta. R equals 1 plus 2 cosine negative theta because it's a positive function. It passes that. Replace that to get 1 plus 2 cosine theta. That's right, with this one, we have A is greater than B is greater than 0. this one, I change it to 1 + 2 cosine pi minus theta. 1 + 2 cosine pi cosine theta plus sine pi sine theta. It's negative cosine theta. That goes to 0. So it fails. Because this equation doesn't look like our original equation. And the pole test. So we have R equals 1 + 2 cosine theta minus R equals -1 -2 cosine theta. It fails. Yes.
Would it matter if it's already made?
Well, remember, when we do this, if for it to pass,
And that's the whole entire equation has to be negative.
yeah, in other words, when we make this thing negative, we take negative the whole thing, it has to end up looking like the original equation. That's
Okay.
what, since it doesn't, it fails the test. It's not that difficult. It's just that we have to go through it to see if it's symmetric.
Because that was the question that I had, that I was thinking about, especially with would it matter if the equation is already made? But if once we change it,
No, because what matters is, can we get it back to that equation?
so it still has to look like.
The original, right? Now points. We'll go from 0 to pi again, since it's cosine. Start at 0. So 1 + 2 times 1 is 3. Pi over 6. 1 + 2 cosine pi over 6 is radical 3 over 2. 1 plus radical 3. Two is 1 plus radical 2. Pi over 3. 1 plus 2 times 1/2. 1 plus 1 equals 2. Two pi over 3. So that puts us in the second quadrant, so it makes it negative 1/2. This is 1 plus 2 negative radical 3 over 2. 1 minus radical 3, 5 pi over 6. Three pi over 4. One minus radical 2. Pi over 4 and at pi. -1 pi. Okay, so these points. So we have 3, 0. Two pi over 3. Be about here. 1 pi over 2. One plus 2.7 pi over 3. There. 2 pi over 3. Five pi over 6 is negative. Negative 1 pi is at 1 pi, so it's negative here. Since it's symmetric about this, it has to go again. Because this is all the points we got, these are the ones we got. Since it's symmetric about the polar axis, just flip it over. That's the beauty of it. We just have to do half of it. That's how come we only went from 0 to pi instead of 2 pi all the way around. Yeah, when they're nice and easy like that, they're easy to graph. Oh no. Polar equation in the form of a rose. It all depends on how many petals we have. R equals 2 cosine 2 theta. For the rose has this equation, A cosine n theta or A sine n theta, where A cannot equal 0. N cannot equal 0. N is even, has 2 petals. If n does not equal to plus or minus 1, And it's odd. And it has end petals. Which one was I looking at? 2 theta. Symmetry. Polar axis. Switch theta with negative theta. So we have r equals 2 cosine 2 theta. R equals 2 cosine negative 2 theta. Because it's an even function, it passes the polar axis test. Theta equals pi over 2 test. Equals 2 cosine 2 pi minus theta. R equals 2 cosine 2 pi minus 2 theta. Two pi, which is 1. Oh, since it goes all the way around, it's just 2 theta. So it passes that one. And pole test. Yeah, another thing is that since it's both polar and vertical line, that's automatically through the pole. Symmetric, but because cosine's an even function, it's gonna be. Now table. We're doing from 0 to pi over 2. At 0 equals 2, so we have 2 comma 0. Pi over 6 2 cosine 2 pi over 6, 2 cosine pi over 3, 2 1/2, which is 1. Pi over 4, 2 cosine 2 pi over 4 makes it pi over 2, 0. Two cosine 2 pi over 3, 2 since it's second quadrant. So it equals -1. Two cosine 2 pi over 2, 2 cosine pi, which is -2. Okay, so our first point at 2, 0. 1 pi over 6, so 1 to pi over 6 is down here. Pi over 4, 0. -1 pi over 3. So it's over here, pi over 3. And -2 pi over 2. Pi over 2, -2. Okay, so it's got to flip around here. So it's around the x-axis. Now across the y-axis. So it's 4 petals. Because we had this original one, we flipped it on the x-axis and the y-axis. Example, like polar equation as a lemniscate. Lemniscates have this conditions. R squared equals a squared sine 2 theta. R squared equals a squared cosine 2 theta. And a cannot equal 0. So these are the conditions for those. So what equation, we're gonna look at r squared equals 4 sine 2 theta. So a equals 2. So lemniscate, the difference between lemniscate and the early one, the rose, is these are more thin, these are longer, propeller shaped. So we're gonna go from 0 to pi over 2, because it's because r squared, it's symmetric about the pole axis and what's the last one? Pole axis and polar axis. So we're gonna look at 0, look at pi over 6, pi over 4, pi over 3, and pi over 2. So r squared equals 4 times sine of 0. Sine of 0 is 0, so 0. R squared 4 sine 2 pi over 6 pi over 3, so it's sine radical 3 over 3. Let's have to go over 2. That cancels, so it's 2 radical 3 pi over 4, so it's r squared. Oh, square root that. 4 sine 2 pi over 4. So pi over 2 is 1, so it equals to 4. So that makes it plus or minus 2. R squared 4 sine 2 pi over 3. 4 radical 3 over 2. 2 radical 3 square root that, plus or minus just close to 2. Four sine 2 times pi over 2 is pi, so that goes to 0. And the graph here. At 0, 0. Pi over 6. It's going to be approximately 2. It's plus or minus, so it's going to be over here also. This is at pi over 6. Then at pi over 4. And pi over 3. Pi over 4 is 2. So it's 2, negative 2. Then pi over 3 is the same as the other one. follow that? It's much easier when you have calculators to do the graph for you. But you notice how I did the lines? Reason I have to do both of these because it was plus minus. We have to square root of them. And because we have a negative R, if this is the R, then it has to have the opposite side of it. Like this one here. This is R, this is negative R. Example 12. Polar equation, a spiral. R equals e to the power theta over 5. Okay, spirals have this format. A cosine n theta, A sine n theta, where A cannot be 0. And n cannot equal plus or minus 1. Must be even.
So
Yeah, like rows, yeah. Because if it's even, we have 2 petals, 2 n petals. And if it's odd, we have n petals. Forget the symmetry. We're going from 0 to 2 pi since it's symmetric. Pi over 2. Actually, this one we have to go all the way around. Because it is a spiral. What this is gonna look like is this. It's gonna start off slow, it's gonna start and then keep on growing like a shell. So we have to go all the way around both sides. Theta R. So at 0, pi over 6, pi over 4, pi over 3, pi over 2, all the way to pi, 3 pi over 2, and we'll keep it going. And then we gotta do the negative side also. We have 0, negative pi over 3, not pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, negative pi, and same as the other one. So 0 at 0 pi over 5. What was it? E. Theta over 5. That makes not more sense. E theta over 5. So it's 0, so it's 1 pi over 6, so pi over 30 E. E pi over 30 pi over 4 So it's E pi over 20. 1.17. I can use pi over 2. I can use pi. 3 pi over 2. Can't use pi over 3. Since that changes with 2 pi over 6, I can't use those. Can't use pi over 6. Pi over 4 is pi over 3. Can't use that one. Pi. 3 pi over 2. Negative pi is 0.53. Make this one 3 pi over 2. So I have radius 1, 0. One 1.17 pi over 4. 1.17 pi over 4. 1.37 is pi over 2. Pi is 1.87. Three pi, so 1 pi over 2. 2.3 pi over 2 is 2.57. Hmm. 2 point, what, 2 pi, was that 2 pi? 2 pi over 5. So that's pretty much how we do it. If you don't have a calculator, it sucks. But with this section, first off, the rest of these are just plugging numbers. That's not the hard part is the test. We have a symmetry test. Is it symmetric about the polar axis, the horizontal line? Is it symmetric about the vertical line? Because you want the x-axis, the y-axis, and the origin, which is the pole. And that's what this one's really testing. And when it gets as far as I wanted to today, because that was very painful. I'm sorry about that. But we're done with that chapter. We're done with chapter 9. Ah, no, we're not. Dang it, but we're not. That's only section 2. We have vectors to go. Vectors are a lot easier. because these polar coordinates are very painful. Vectors are magnitude, direction, and we can add them, we can subtract them, we can multiply them, we do all sorts of algebra to them. And once we do that, because we're running out of time, after we finish this chapter, then we're gonna do chapter 11. And then whatever time we have next week. Because we only have 3 days left of classes. And we're gonna do vectors next time. And then partial fractions after that. And then whatever we have left, we'll do in chapter 10, which are the conic sections. But I'm gonna remove those off the tests. We won't be tested over those. But we'll cover as much as we can. I was really hoping to be done this week so we can have time to review and do all that stuff, but my computer dying and the power outage and all this other stuff really did a job on us. So yeah, that's what we're gonna do next.